My journey into the science of the medieval Islamic world will take me through Syria, Iran, and North Africa. I started in the back streets of the Egyptian capital, Cairo, with the realization that the language of modern science still has many references to its Arabic roots. Take scientific terms like algebra, algorithm, alkali. I instantly recognize these words as Arabic. And these are at the very heart of what science does. There will be no modern mathematics or physics without algebra, no computers without algorithms, and no chemistry without alkalis. Surprisingly few people in the West today, even scientists, are aware of this medieval Islamic legacy. But it wasn't always so. From the 12th to the 17th century, European scholars regularly refer to earlier Islamic texts. I have here copies of some pages of the book Liber Abaci by the great Italian mathematician Leonardo Pisano, otherwise known as Fibonacci. What's fascinating is that on page 406 is a reference to an older text called Modum Algebra et al-Muqabala, and in the margin is the name Mahomet, which is the Latinized version of the Arabic name Muhammad. The person he's referring to is Muhammad ibn Musa al-Khwarizmi. In fact, Arabic names crop up in many medieval European texts on subjects as varied as map-making, optics, and medicine. But I want to start with al-Khwarizmi because his work touches on a crucial aspect of all our lives today. It's thanks to al-Khwarizmi that the European world realized that their way of doing arithmetic, which was still essentially based on Roman numerals, was hopelessly inefficient and downright clunky. If I ask you to multiply 123 by 11, you may even be able to do it in your head. The answer is 1,353. But try doing it with Roman numerals. You'd have to multiply CXXIII by XI. It can be done, but trust me, it's not fun. Al-Khwarizmi showed Europeans that there's a better way of doing arithmetic. In his book entitled The Hindu Art of Reckoning, he describes a revolutionary idea. You can represent any number you like with just 10 simple symbols. The idea of using just 10 symbols, the digits from 1 to 9, plus a symbol for 0, to represent all numbers from 1 to infinity, was first developed by Indian mathematicians around the 6th century AD. And I can't overstate its importance. Let me show you. Here are the numbers in Indian Arabic numerals. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here are the numbers we're more familiar with in the West. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see the similarity between these numbers, in particular, for instance, the digits 2 and 3. If I tip this sideways, you can see now how they look like numbers 2 and 3. And what's powerful about these digits, this numerical system, is how it's simplified arithmetic calculations. But al-Khwarizmi and his colleagues went further than just translating the Indian system into Arabic. They created the decimal point. This text, written a century after Khwarizmi, is by a man we know only as al-Uqlidisi. Here he shows that this same decimal system can be extended to describe not just whole numbers, but fractions as well. The infinity of possibilities that lie in between the integers. Here's a copy of al-Uqlidisi's manuscript, where he showed how the decimal point is used for the very first time. He describes it by using a dash. Here are the digits 1, 7, 9, 6, 8, and you can see there's a small dash over the 9 indicating the decimal place. The idea of the decimal point is so familiar to us that it's hard to understand how people managed without it. But like all great science, it's blindingly obvious after it's been discovered.